Hi, I'm Rebecca Bates.
I'm Brittany Hernandez.
And this is Voltage Dividers in S domain. When solving circuits in time domain, which have inductors and capacitors in them, calculations can get really complex. So we can simplify this by transferring everything over to S domain. And in S domain, we can define inductors, capacitors, and resistors using impedance, which is defined as Z. And we can also use Ohm's law while we're in the S domain, and we're going to use impedance instead of resistance. And since we're in the S domain, we're using fancy capital letters instead of lowercase letters, which would be time domain. So another important function for the S domain is the transfer function. The transfer function is H of S equals V out over V in. And so because of this, we often want V out, which is where voltage dividers come very in handy in S domain. So let's review how to do a voltage divider in time domain real fast. We'll start with our V in source and then two resistors in series. We have our R1, and then let's say we want to know the voltage over our second resistor here, and that's going to be our V out. So we can use our voltage divider, which is V out equals our R of interest. In this case, that's going to be R2 over the total resistance. So since they're in series, we're going to add them up, R1 plus R2, and then that is multiplied by V in. So we can then apply this to the S domain now. So this is going to be V out equals our total resistance, or in this case, it's going to be impedance. So we're going to do Z of interest is over our total Z, and then times that by our V in. Now let's do an example.
So to start, let's draw this circuit in S domain. As we remember, the transfer function is going to be H of S equals B out divided by B in. This example is going to be solved by voltage divider. To begin the voltage divider in this example, we know that these two impedances are in parallel. Now, to solve for the voltage in this impedance, we need to solve first for C equivalent, which is going to be the voltage parallel with these two. And we get 40 divided by 4s plus 10. This is going to be our C equivalent. That way, we end up with a circuit something like this. In order to find B out, which is right here, we do a voltage divider, and it's going to look something like this. B out here, we have the impedance of interest, which is C equivalent, divided by total impedance, which is 2 plus S plus C equivalent. Now that we have that, let's plug it in. Now, let's just solve for this expression. Let's simplify it. So to simplify this denominator, we're going to multiply these two terms by this to have a common denominator. Now, we see that the two denominators of the two fractions, they cancel out again. So that is one nice thing that happens a lot in voltage dividers. We can leave it like that or simplify it a little bit more. So having that is going to help us to get the transfer function, which is just going to be this, because we divide B out divided by B in. And even though in the beginning it looks like a voltage divider makes it harder, it actually makes the whole circuit a little bit more simpler and easier to solve. So that is the transfer function.